In question 10 of this exercise, we are given this figure 6.64, and here's what the problem statement says. Nazima is fly fishing in a stream. So Nazima is this girl, she is sitting on this platform and she is fly fishing. Fly fishing is a kind of fishing in which you have an artificial bait at the end of your fishing string. Fishing string has a small bait at the end. So that's a type of fishing. So the problem statement says the tip of her fishing rod is 1.8 meter above the surface of the water. So this here is the tip of the fishing rod. Let's call it point A. This is 1.8 meters above the surface of the water. The surface of the water is here, and the point A is 1.8 meters above the surface of the water. And the fly at the end of the string rests on the water 3.6 meters away and 2.4 meters from a point directly under the tip of the rod. So this point here, which is directly under the tip of the rod, let's call it point B. And now this point here is where the fly is, the fly at the end of the string. Let's call it point C. We are told that this point is 3.6 meters away and 2.4 meters from a point directly under the tip of the rod. So you can see that BC is 2.4 meters, and this point here, whatever this point is, let's call it X. So the distance, this point X is basically directly under Nazima. So the distance between C and X is 3.6 meters. So 2.4 meters plus 1.2 meters. So the distance between B and X is 1.2 meters. Now, then the problem statement says, assuming that her string from the tip of a rod to the fly, so from the point A to the point C, assuming the string is taut means completely straight, there is no slack in the string. How much string does she have out? So how much string is out, basically out of the fishing rod? And that is simply the length of AC. So in this first question, we have to simply find the length of AC. Then the question says, if she pulls in the string at the rate of 5 centimeters per second, what will be the horizontal distance of the fly from her after 12 seconds? So let's first solve the first question, in which we are required to find the length of AC, the length of the string that is out. So for that purpose, let's focus on triangle ABC. So let me highlight this triangle. Triangle ABC is this triangle, and this triangle is a right angled triangle. One length is 1.8 meters. The other length BC is 2.4 meters. So the hypotenuse can now be found easily using the Pythagoras theorem. So we have AC square is equal to AB square plus BC square, correct? So let's plug in the values. So AB is 1.8 meters, so we have 1.8 meters square, and then BC is 2.4 meters, so we have 2.4 meters square. Now 1.8 square is 3.24, so we get 3.24 meters square, and then 2.4 square is 5.76, so we get 5.76 meter square. And now 3.24 plus 5.76 is exactly equal to 9, so we get 9 meter square. So AC square is 9 meter square, and this means that AC, now you take the square root, AC will be equal to 3 meters. So the first answer is 3 meters. The length of string that she has out is 3 meters. Now let's answer the second question. Alright, so the second part of the question says, if she pulls in the string at the rate of 5 centimeters per second, so she starts pulling in the string. So basically the string that she has out, the length of that string will start to reduce. Okay, so what will be the horizontal distance of the fly from her after 12 seconds? So as she starts to pull in the string, what will happen is the tip of her string, the position of the fly, this will start moving towards the left. So after 12 seconds, suppose that the tip of the string or the position of the fly, it comes to this point here, which is, let's say, point D. Okay, and let's join A to D. So the length of the string that she has out after 12 seconds will reduce from AC to AD. And we have to find the horizontal distance of the fly from her after 12 seconds. So we basically have to find this distance from D to X. Let me actually highlight that distance. So we have to find the distance from D to X, this distance. And to find that, we can find dB, and we already know bx, so we can find dx. Okay, now our task then is to find the length of dB. So to find dB, we will consider the right angle triangle ADB. So ADB, this triangle, and we will apply the Pythagoras theorem to this triangle to find the length of dB. So how can we apply the Pythagoras theorem? Well, we have this side AB, we know is 1.8 meters. Do we have AD? Do we know the length of AD? Well, to find the length of AD, we will have to find out the reduced length of the string that is out. So because Nazima is pulling the string in, the length of the string that is out, that is beyond point A, that will reduce. So what will be the reduced length of the string that is out? So let's find that first. So the reduced length is, which is basically AD, will be equal to the original length. The original length was 3 meters. We calculated just now as the first part of the answer. So the original length of the string that is out is 3 meters. And then she is pulling in the string at the rate of 5 centimeter per second for a total of 12 seconds. So the reduction in the length of the string that is out will be 5 centimeters per second into 12 seconds. So from the original length of the string which is out, you subtract this reduction in length, and that will give you the reduced length. Okay, so make sure that you understand this. So we will get 3 meters minus 5 into 12 is 60. So you will get 60 centimeters. Make sure you get the units right. So 3 meters minus 60 centimeters is 2.4 meters. You can basically write 60 centimeters as 0.6 meters. So 3 minus 0.6 is 2.4. So now you have the length of AD, the reduced length of the string. So now you can apply the Pythagoras theorem to triangle ADB. So DB square you can now write as AD square minus AB square, and you have the value of both AD as well as AB. So AD is 2.4, so we have 2.4 meters square, and then minus AB is 1.8 meters, so we have 1.8 meter square. Okay, so 2.4 square is 5.76, so we get 5.76 meters square, minus 1.8 square is 3.24, so we get minus 3.24 meters square. And now 5.76 minus 3.24 is 2.52, so we get 2.52 meter square. Now we will have to take the square root on both sides. So to find dB, we take the square roots, and dB we will get as the square root of 2.52 meters. Now to find this square root, you can either use the prime factorization approach. You can prime factorize 252 and find the square root, or you can use the long division method to find the square root. I'm not going to show that calculation here. I'm directly going to make use of the fact that this is roughly equal to 1.587 meters. And what you can do is pause the video for a few moments and verify this calculation. Verify that this square root will be roughly 1.587. Okay, now we have found dB, but what we really want to find is dx. Observe the figure carefully. D is this point, x is this point here. We want to find the length of dx because we want to find the horizontal distance of the fly from Nazima. So now dx is easy to find. Dx is simply equal to db plus bx, and we have both these lengths. db is 1.587 meters and bx is 1.2, that we already know. Bx is 1.2 meters. So the sum will be 2.787 meters, and we can round this off to 2 decimal digits as 2.79 meters. Okay, so the answer to this question is that after 12 seconds the fly will be about 2.79 meters distance away horizontally from Nazima. Okay, so with this we have completed question number 10 of this exercise. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.